So now that you've read section 2.2, let's go over the notes. So I have that Galileo showed that the Copernican view was correct by showing that there were problems with the Aristotelian view, or Aristotle's view. So Aristotle believed that when dropping two objects of different weights, that the heavier object would arrive at the ground before the lighter object, and Galileo showed that this was false. He used the Leaning Tower of Pisa and dropped objects of different weights from the top. And objects of various weights fell together and hit the ground at the same time. And then you watched a video that was kind of about this. Then the inclined plane experiments. Aristotle believed that a push or a pull was required to keep an object moving. Galileo disagreed with Aristotle and believed that an object would continue moving in a straight line without any interference. Using an inclined plane, Galileo did a couple of experiments. Rolling down the inclined plane, a ball would gain speed. Rolling up, the ball would lose speed. On a flat surface, Galileo believed that the ball would continue rolling, and he thought that a ball would eventually stop because of friction. So in this part, I included the sketches for you of the three things that were in your textbook. So in the first one, a ball released at the top on one side would travel down and then up until it almost reached the initial point. He thought that friction prevented it from reaching the exact same height when it was released. So it's really close to the same height, but not quite. In the second one, he reduced the angle of the upward slope. So you can see at this one, it's not as steep as the downward one. And with this one, the ball reached the same height. In order to do this, it actually had to travel farther. So you can see, if you look at this first sketch, that the ball actually moves farther than it did in the first one. And continually changing the angle until the second slope was flat, he concluded that the ball would travel forever because it would never reach its original height. And then he did a little bit about looking at the speed of the ball. So using that same setup, he considered the speed. Since the downward motion of the ball from the first plane is the same for all cases, the speed of the ball when it starts up the second plane is the same. So if it moves up a steep slope, it loses speed faster. And if it moves up a shallower slope, it loses speed slower. And in the extreme case where there is no slope and it's just a horizontal plane, the speed of the ball will stay constant. And without any forces to slow down, the ball will tend to move forever and not slow down. And this is a property called inertia. So the questions that were on this sheet for you to answer, 4 through 6, gave you some information. Galileo discovered that objects will fall and pick up equal speeds, whatever their weights. In number 5, he discovered that a moving object will continue in motion without the need of a force. And number 6, inertia is the name given to the property of matter that resists a change of motion. And I don't expect you to understand the concept of inertia at this point in time. It's just being introduced here. So in the video demonstration, the first one, do heavier objects fall faster than lighter objects? So the things that I wrote down that I observed is, first, they dropped a pillow and a stove, and the stove hit the ground first. And next, they dropped two balls of different weights, a cannonball and a soccer ball. And the cannonball hit the ground first, and the soccer ball was slower. And then finally, they dropped a tire and a car, and both hit the ground at the same time. So if part of this was to prove whether Aristotle or Galileo was correct, and we at this time, as far as we've read in the book, Galileo is the one who's correct, then the question in my mind is, why do all of the objects not hit the ground at the same time? And then we kind of learned in the video that the difference between the objects is the amount of air resistance, or how the air affects their falling to the ground. The pillow and the soccer ball have very small masses, and they're significantly affected by the air. When they dropped the tire and the car, neither object is affected a lot by air resistance, so they fell at the same time, even though they have very different masses. So I'm hoping that you understood this video and that you kind of got this general information out of it. The second one is really a favorite of mine because it was done here in Cleveland, and I think it's just a very impressive video. So the things I observed, first they dropped feathers in a bowling ball, and the ball hit the ground first and the feathers took a really long time to fall. Next, they removed the air in this very, very large vacuum chamber, and it's in Cleveland down at NASA. And when they did this, they dropped the feathers in the bowling ball, they hit the ground at the same time, which I think is just really impressive because it's obviously not something that we can just do ourselves. So what did I wonder? It's just a really impressive video to think the feathers and a bowling ball, when they're dropped from this height, they're going to hit the ground at the same time. So what I learned was that the difference between when there was air and when there is no air is huge. It's just really hard to believe that the feathers in the bowling ball really fall at the same time, but the video proves this. So this really reinforces the idea that air resistance has a huge, huge effect on falling objects. So in spite of the fact that we think about things falling to the ground at different rates, what we're not typically taking into consideration is the fact that there's a lot of air resistance going on. So I'm really hoping you guys like these videos also. And I hope that you found that you understand a little bit more about these things falling to the ground and the air resistance. So now you're going to move on and we're going to learn about Sir Isaac Newton. And in my opinion, Sir Isaac Newton is really an impressive scientist, and he lived in a time where things were obviously very different. Technology was not as sophisticated. And so I'm going to have you read a biography about him. I've got a biography in your packet, and actually this starts on page 10. I see I have a typo here. It isn't on page 11. It starts on page 10. And it continues through to page 14 in your packet. And then there are some questions on page 15. And I'm going to ask you to answer these questions. There's some that are just basically about the reading. And then there's a couple of little deeper questions kind of asking your opinion and your thoughts about all of this. So in the next video, I'll go over some of the answers and then we'll proceed from there.